Hello and welcome to this video on energy. This is acting as a sort of summary over energy and encapsulation of a higher level concept that typically isn't directly touched upon on the AP, but is useful for understanding how work works on a macro scale. Consider three ramps, the blue, the red, and the black. And I put a ball on the top. Now, in a frictionless situation, no matter which path the ball would go down, the change in energy would be identical. Up at the top, they would all have the same amount of Eg, because Eg is entirely dependent on height, and they're all to the same height. But at the bottom, the amount of kinetic energy would be the same because the height change is all the same. Without friction, the gravitational potential energy completely converts to kinetic energy. What this tells you that it doesn't matter how a ball gets to the bottom of a hill or ramp, provided there's no friction or no other forces doing work, the amount of energy transferred from Eg to other forms is always the same. In fact, I could go off the side over here, and right before I hit the ground, the amount of Ek would be the same. No matter how you get down to that lowest level there, the amount of gravitational potential energy is the same, 0, which means it has to have been transferred into other forms or has to have done work in other forms to leave the system. That idea there that the Eg has done work also tells us that the force gravity, or the work done by force gravity, is the same in each of these circumstances. 1, 2, 3, 4. And this works because while the distance they are traveling increases, so does the angle between force gravity and the direction of travel, and it will proceed at a constant rate. In other words, the amount of work done by gravity to get to point 1 is the same as the amount of work done by gravity to get to point 2, to get to point 3, to get to point 4. We refer to this force not mattering what direction you travel, what path you travel, as the force being path independent. Meaning that no matter which way you go, the amount of work done by force gravity is the same. This would even be true if I drew a particularly ridiculous thing. Even if the ball followed this path for whatever reason, by some miracle, the amount of work done by gravity would be the same as here, 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 and here. Now this is also true no matter what height I'm at. I could be here, and the amount of work done to get to here, 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 or here would all be the same. I could be higher or lower. The only forces that are path independent are conservative forces. In our case, that would be the force of gravity and the force exerted by a spring. It only matters where you start and end, not how many steps you go through to get there. This also brings us back to the idea that the amount of Eg is the same at each height. The amount of Eg I have here is the same amount as the amount of Eg I have here, as I have here, and I have here, and I have here. Because the amount of work done to get from that point, either from the ground up or from the peak down, is the same. At the same height above the ground, you have the same amount of Eg. Now, if we were to talk about friction, suddenly the path you take to get to the bottom matters a lot. Because while you will have the same amount of Eg here, regardless of how you go about it, if you fall off the edge and don't have any friction, versus you go down the shorter path in blue, slightly longer path in red, or the longest path in black, the amount of friction they're going to experience from the slope increases with the distance. In other words, the way you go, the path you take, determines how much work is done by force friction. Friction and any non-conservative force is what we call path dependent. any non-conservative force qualifies this way because the way you go about things determines how much work is done by the force. I'd like to put this a slightly different way. Previously, we talked displacement versus the distance. And while going from here to here around a football field would be give the exact same displacement as going from here to here. The amount of time, the amount of effort it takes, how tired you are after running that is different because the amount of work done on the blue path is greater than the red one. Most of the forces we have experience with are path-dependent forces, so this makes sense. This is something we almost intuitively understand. But it is important to understand that there are some forces where this doesn't matter, where no matter where you are, how you got there, the amount of work done is the same. It can save you time, effort, and energy to remember the work done by gravity to get from here to here is the same as the amount of work done by gravity to get from here to here, or here to here, and so on. Anyways, thanks for watching. Have a good one.